Hello and welcome back to the Chemistry Made Simple podcast. In this episode, I'm going to be talking about making sure you use the right units in chemistry calculations. I'm going to talk about the impact of that, and I'm going to talk about what the correct units to use are. Stay to the end for my bonus tips of how to get the best out of doing your chemistry calculations, how to get the top marks. So I'm Matthew McCarrier, and as well as being a chemistry tutor, I coach and mentor chemistry students too. Now let's get on with the episode. So this episode is about avoiding the calculation chaos that happens if we're unsure of the units or we use incorrect units. So today we're going to be talking about using the correct units. We're going to talk about the impact when we don't use that, and we're going to talk about what those correct units are. Stay to the end for my bonus tips on how to maximize the number of marks you get from your chemistry calculation exam questions. Okay, so what is the impact of using incorrect units? Well, they might seem quite small, but actually it's stipulated by the exam boards that A-level chemistry must have at least 20% of the marks reliant on doing calculations, on testing your ability to do the mathematical calculations involved in chemistry. So that's at least 20%, but it's actually often 30 or 40% of those marks. And every time you do a calculation where you're using an incorrect unit, you're going to be dropping marks. The marks won't be awarded. That's part of what the examiners are testing when they do these questions. And when they give you units that you might consider misleading, but they're there to test your understanding. So if you do this a number of times across an exam, or in fact across your series of chemistry exams, it's going to be very easy for you to drift down a grade from what your chemistry knowledge should really be getting you. So this really is important to pay attention to the units. So we're going to talk about some of the most common ones, some of the most common units that you'll need to use in chemistry calculations. We're going to be talking about the units for volume, amount of substance, concentration, temperature, pressure, and energy. Now don't switch off if you think you already know them. So do all the students that are dropping marks on them. Stay with me so that you have a firmer understanding of which units to use. So we're going to talk about volume first, and let's talk about liquids. So this is liquid substances or solutions. The same unit will apply in both cases. We use DM3, the decimeter cubed. Let's dig into what that unit actually is. So a decimeter means a tenth of a meter, in other words 10 centimeters. A decimeter cubed is that 10 cubed, that 10 centimeters. If we cube 10, we come up with 1,000. A decimeter cubed is 1,000 cubic centimeters. And you may well recognize that unit as being the same as a litre. And it is, but you are expected to refer to it as the decimeter cubed at all times, I know. One tip I have for you is to take care when using titration data, when you've got titration data in an exam question or data you've obtained from doing the titration yourself in lab. So usually you will have those values, you will record those values in cubic centimeters CM3. Or maybe you'll see that or write it as milliliters. Milliliters and cubic centimeters are the same thing, of course. When you come to do the calculation to work out the concentration of whatever, the amount of moles of whatever that have reacted, then you need to make sure that you're converting your volume into decimeters cubed. So take your centimeters cubed value and divide by 1,000 to get the number of decimeters cubed. How about for gases? We have a different approach for gases. We use the meter cubed. In fact, the meter cubed is the SI unit for volume. And this is really important. Usually when you're using volume of gas and in a calculation, it's because you're using the ideal gas equation. And when you're doing that, you must use the meters cubed. It won't work. You'll get incorrect results if you're using decimeters cubed or in fact anything else other than the meter cubed. Now you might see other units quoted for gases, and that's fine. You might see, for example, the molar volume of a gas being referred to as being 24 decimeters cubed at room temperature, or even 24,000 centimeters cubed at room temperature. And that's fine. Statements like this are there to help you calculate the amount of substance, the amount of a gas that is present in an experiment or in the question. It's fine to use those units to calculate the amount of substance, but then if you need to carry that information forward and use it in the ideal gas equation, that's when you must use meters cubed. Another concept that students often struggle with is the units for amount of substance. The only unit that we should use for the amount of substance is moles, the abbreviation MOL. And I talked about the reason for that in a fairly recent episode, and I'll put a link for that in the video here. Now, the thing with the amount of substance is we're usually given the amounts that we're using, measuring, whatever, in grams or in decimeters cubed or centimeters cubed. Something that is a convenient physical measurement that we are taking or someone is recording. But as I've talked about before, those are telling us nothing about the amount of substance. If we have 1 gram of one substance and 1 gram of another, there could actually be very different amounts of substance in terms of how many molecules or atoms are present in that gram. And it really does make a difference. When we write a chemical equation, we're talking about the number of atoms or the number of moles that are reacting with each other. Those numbers don't mean grams or decimeters cubed. It just doesn't work like that. The reality is that calculations and equations don't work with these units. You must always convert to moles. And that's not too difficult. So if you have grams, for example, and you need to work out how many moles that is, just divide the number of grams by the relative formula mass of that substance. And of course, if you're working out the amount of substance, or the exam question is asking you about how much of something, it's usually asking you about the number of moles. There will be occasions where it's asking you about grams and it'll be very clear, but usually it's in moles. If you're in any doubt, quote it in moles. Next we have concentration, and concentration is the amount of substance in a given volume. Now the amount of substance is in moles, of course, and the volume we tend to measure in is decimeters cubed. So the unit is moles per decimeter cubed. So we should write that MOL for mole, dm to the -3. You might also see it written as mol / dm3. If you're studying A-level chemistry, it's expected that you use the abbreviations correctly. If you're studying elsewhere, a different syllabus, please check with the requirements of your syllabus whether or not mol / dm cubed is going to be acceptable or not. Always mol dm -3 is going to be acceptable because that is the proper unit. Often we will be given the concentration of something in grams per decimeter cubed, and if that's the case we do have to convert it. It is a simple conversion. The moles per decimeter cubed value is equal to the grams per decimeter cubed value divided by whatever the molar mass of that substance is. Temperature is another one that tends to confuse some students. Temperature in a chemistry calculation is always in Kelvin. Kelvin has the abbreviation capital K. We're usually given the temperature in degrees Celsius. There is an easy conversion, and the conversion's easy because a unit of Celsius and a unit of Kelvin are the same size as each other. They just have a different starting point where their zero is. The Kelvin scale starts with its zero at absolute zero, which is -273 Celsius. That means to convert from Celsius into Kelvin, you add 273 to the Celsius value. For example, 25 degrees Celsius is 298 Kelvin. That's probably one you come across quite a lot. Next we have pressure. And pressure is in the units of pascals. Pascals have the abbreviation capital P, lowercase a. You're very often given pressure values in kilopascals. But if you need to use that pressure in a calculation, and that's usually going to be the ideal gas equation, you need to convert it. You need to convert the kilopascals to pascals. Again, it's an easy one. Just multiply the kilopascal value by 1,000 to get how many pascals. Now you might see kilopascal values quoted elsewhere. For example, when you talk about room temperature and pressure, that pressure is very often quoted in kilopascals. You're not going to do a calculation with that, so there's no need to do a conversion. Similarly, atmospheric pressure is very often quoted in kilopascals. And again, unless you need to use the pressure directly in a calculation, just leave it as kilopascals. You don't need to convert it unless you're going to be doing a calculation involving what that pressure is. And when it comes to energy, we might be talking about the total energy change of a particular reaction, in which case we're talking about kilojoules. Kilojoules has the abbreviation lowercase k, capital J. Also, very often we're talking about the energy change per mole of substance, and in that case it's kilojoules per mole is the unit, and that's lowercase k, capital J, and then mole to the -1. There is one exception, and that's when we're using this equation Q equals mc delta T, C being the specific heat capacity. This is the equation that you use when you're calculating the energy change when you do an experiment with a calorimeter. Q is the energy change, M is the mass of the water or other fluid that you're measuring the temperature change of, C is the specific heat capacity, and delta T is the temperature change that happens when you combust a quantity of whatever. In this case, the energy change Q is in joules, and that's because the units of the specific heat capacity refer to joules rather than kilojoules. So that is one exception that you must remember, and once you've got the energy change and you need to use that to work out the energy change per mole, don't forget to then convert it into kilojoules. Now, there was a lot of important information about the appropriate units to use there. Now, I would recommend you save this video, make sure you know where it is so you can come back and refer to it. Add it to a playlist, subscribe to the channel so that you've got easy access to it, because you are probably going to want to come back to that and refer to it at some point. Now, thank you for staying to the end. These are the bonus tips I was talking about, the calculation pro tips. The first one is a golden rule, really. It's make sure you convert to the correct units before you do any calculation. Make sure those units are correct and do the conversion if they aren't. Otherwise, you're going to be introducing errors from the very first step. Speaking of introducing errors at each step, never round up your results until you get to the final result, until you get to the end of the calculation. When you've done the first row of a calculation, keep that number in your calculator. Don't round it up yet. Only round up when you get to the very end. And when you do so, and when you do round up and quote your answer, quote it to the least number of significant figures that there are in any of the data in the calculation, in the question. What do I mean by that? If you're given some of the data to 3 or 4 significant figures, for example, but another to only 2, then that's what you should quote your answer to. 2 decimal places, the least number of significant figures in the data you were provided or used. Just a caveat, occasionally in questions you're told how many significant figures or decimal places to use, and if that's the case, do exactly what the question is telling you to, because otherwise you will get marked down. And then finally, make sure you do a sense check when you get to your end result. Make sure that the answer you come up with makes sense with the narrative of the question. If you've got an energy change that suggests a reaction was exothermic and the question's narrative suggested it was endothermic, just make sure you've understood the question properly, or have you done the calculation correctly? One frequent example of when this happens is when you're calculating Q, that enthalpy change when you use the calorimeter. So Q will always come up with a positive energy change. It's the amount of energy that got passed from the combusting substance into the water. Once you've calculated Q and you go on to use it in the rest of the calculation and the question, you need to make sure that value is not only in kilojoules, but it's also negative. That is energy that was given out from that substance when it combusted. It's exothermic, and therefore that value needs to be made negative, and that is a really, really common mistake. There, that was worth staying to the end, wasn't it? Now, if you have any tips of your own, put them into the comments. I'd love to see those, but also other students listening to this or watching this are going to want to see that as well. It would be really helpful. So thank you for being here and listening. I really appreciate it. I really appreciate to my Patreon patrons. Thank you so much. Your support really helps with this podcast. Now, if you're not a patron of the podcast yet, you can do so easily. Just go to patreon.com/chemistrymadesimple. I'd love to see you there. If you want to get in touch in other ways, you can do so using my Instagram, where you'll find me at Chemistry Made Simple, or you can use my email, that's matthew@chemistrymadesimple.net. And if you'd rather leave me a voice note, then you can do so at chemistrymadesimple.net/voice note. If this podcast has been worthwhile to you, don't forget to share it with someone in your new class, someone that you know will also benefit from it too. That'll be really welcome for me, but also your friend will thank you too. So that brings this episode to a close. I'll look forward to seeing you again in the next one, and until then, look after yourself and goodbye. So here's those details again. Don't forget to subscribe to this channel. You can also leave me a voice note, contact me on Patreon, DM me a message on Instagram, or use my email address. And I will get back to you when you do get in touch.